An engineer opens the monthly invoice and finds $3,200 sitting under a line called EC2-other. No service name, no obvious cause. Drill in, and it's NAT Gateway data processing on traffic that was headed to S3 the whole time and never actually left Amazon Web Services. You found stack lessons. Smart move. Let's continue. By the end of this video, you'll be able to trace the billing path of any packet and pick the cheapest way to move it: gateway endpoint, interface endpoint, CloudFront, or NAT Gateway. This is the cost domain that hides on the invoice instead of the diagram, and one routing choice can swing hundreds of dollars a month. Back in the VPC Foundations episode, we built the plumbing, subnets, route tables, internet gateways, and NAT gateways for private outbound access. Then, in the private connectivity episode, we added VPC endpoints, gateway endpoints for S3 and DynamoDB, and interface endpoints over private link. Today we look at those exact same components through one new lens, what each of them actually costs to move a single byte. 4 terms will anchor everything today. Data transfer out, also called egress, is data leaving Amazon Web Services for the public internet, and it's billed per gigabyte, while inbound is always free. Cross-AZ transfer is private traffic hopping between 2 availability zones, and it bills on both sides. The NAT data processing charge is the per gigabyte fee a NAT gateway adds to every byte it touches, no matter the destination. And cache hit ratio is the share of requests served from a cache instead of the origin. The higher that number, the less egress you pay for. Here's what makes this domain sneaky. Every box on your architecture diagram is a service you chose on purpose. But the arrows between those boxes, the data moving along them, never show a price tag. Data transfer is invisible on the whiteboard and very real on the invoice. And at scale, those arrows can cost more than the boxes. So let's draw the map. There are 4 billing zones, and each boundary you cross starts a meter. At the top, same AZ traffic over private IP addresses is completely free. That's the only truly free path. Cross one availability zone, and you pay a penny per gigabyte. But here's the catch. It bills on each side, so a round trip is effectively 2 cents. Cross a region, and the standard rate is 2 cents a gigabyte for most region pairs, with some adjacent pairs like US East 1 and US East 2 running closer to a penny. Intercontinental routes, US to Asia Pacific or South America, are higher than the standard 2 cents, though still well below the internet egress rate. And leaving Amazon Web Services for the public internet is 9 cents a gigabyte for the first 10 terabytes. One thing that surprises people, inbound traffic from the internet is always free. You only pay to send data out. If the numbers won't stick, picture Amazon Web Services as a city with toll roads. Driving on your own street, same AZ, private IP costs nothing. Crossing a bridge into another neighborhood charges a toll in each direction, and that's exactly how Cross-AZ works. Driving all the way to another city costs more still. That's cross-region. And leaving the country entirely is the most expensive trip of all. That's internet egress. Same idea every time. The farther the boundary, the higher the meter. The Cross-AZ charge hides a second surprise. It bills a penny per gigabyte on the sending side and another penny on the receiving side, so a single gigabyte between zones really costs 2 cents. And here's the part that catches people. If 2 instances in the same AZ talk to each other over public or elastic IP addresses, you pay that same penny per gigabyte, even though they share a data center. Private IPS in one AZ would have been free. And this isn't a rounding error. Datadog's 2024 State of Cloud Cost report found that Cross-AZ traffic drives roughly half of all data transfer costs, and it showed up in 98% of the organizations they measured. Microservices spread across zones without any AZ affinity routing are the classic offenders. The fix is simple to say, keep chatty service pairs in the same zone. So that's the map. Same AZ private IP traffic as the one free path, and every other boundary, zone, region, or internet starts a meter. Now let's look at the one component that adds its own meter on top of all of that, the NAT Gateway. The NAT Gateway stacks 3 separate charges. First, it bills 4.5 cents an hour just for existing. That's about $33 a month before anything moves. Second, it adds 4.5 cents for every gigabyte it processes, regardless of where that gigabyte is going. Third, if the traffic is bound for the internet, the standard 9 cents a gigabyte egress charge stacks on top. Add those last two together, and the true cost of internet-bound traffic through a NAT gateway isn't 4.5 cents, it's 13.5 cents a gigabyte. For high availability, you'll often deploy one NAT gateway per AZ, and that's the right call for resilience. But remember, each one bills independently. 3 zones, 3 gateways, at 4.5 cents an hour, comes to approximately $98 to $99 a month before a single byte of data has moved. Over a year, that's more than $1,100 just for the gateways to be there. So why does this catch experienced engineers? A few reasons. First, in older Cost Explorer views, these charges land under a label called EC2-Other, not a line that says NAT Gateway, so they're genuinely hard to spot. Second, the VPC wizard historically created a NAT gateway automatically, which seeded thousands of unintended gateways across accounts. Third, every dev, staging, and QA environment gets its own, costing about $33 a month each whether anyone uses it or not. And fourth, the big one, the meter runs on all traffic the gateway touches, including traffic to Amazon Web Services that never needed a detour through it in the first place. Here's exactly how that plays out. A team runs nightly batch jobs writing 6 terabytes a month to S3, and that traffic routes out through the NAT gateway. 6,000 gigabytes at 4.5 cents comes to $270 a month in processing fees for traffic that never touched the public internet. It just looped through the NAT because no endpoint existed. They added a free S3 gateway endpoint, and the NAT charge for that traffic dropped to 0. All of it gone, and under an hour of work. This is the single highest return change in Amazon Web Services networking, so make it a reflex. When a private subnet needs S3 or DynamoDB, the answer is a gateway endpoint. It's free, it needs no application code change, and it performs better than the NAT path. Never route S3 or DynamoDB traffic through a NAT gateway when the question asks for the most cost-effective solution. And this comes straight from the Amazon Web Services VPC pricing page. There are no data processing or hourly charges for using gateway-type VPC endpoints. Read that carefully. No per gigabyte fee and no hourly fee either. Gateway endpoints are genuinely free. That's what makes swapping S3 traffic off the NAT gateway a pure win with no downside. We covered the mechanics in the private connectivity episode, so here's the quick refresher on why it works without touching your code. A gateway endpoint adds a route to your route table pointing at the S3 prefix list. Your subnet already has a catch-all route, sending everything to the NAT gateway. When both exist, longest prefix match decides. The specific S3 route is more specific than the catch-all 0/0, so S3 traffic follows the free endpoint path and everything else still flows to NAT. No application change, just one route table entry. Put a number on it. A VPC routing 5 terabytes a month to S3 through a NAT gateway pays about $225 in processing fees. Move that same traffic onto a gateway endpoint and the cost is 0. Same destination, same data, Same performance. The only thing that changed was the path. Now, gateway endpoints have a hard limit. They only cover S3 and DynamoDB, nothing else. So how do you reach the other services privately and cheaply? For ECR, CloudWatch, Secrets Manager, SSM, and hundreds more, you use interface endpoints over private link. Those bill about a penny an hour per Z plus a penny per gigabyte processed. That penny per gigabyte is 78% cheaper than NAT's 4.5 cents. But unlike a gateway endpoint, there's a fixed hourly cost you have to earn back. Line them up side by side. The interface endpoint charges a penny per gigabyte and a penny per hour per AZ, drops a private network interface right into your subnet, and gets cheaper per gigabyte as volume climbs. And since 2022, cross-AZ private link traffic to an interface endpoint is free, which simplifies multi-AZ designs. The NAT Gateway, on the other hand, charges 4.5 cents on both the hourly and the per gigabyte side, but it can reach anything on the internet, not just Amazon Web Services services. For low volume, occasional access to one service, NAT can actually be cheaper overall. The volume is what tips the balance. So here's the decision rule. The interface endpoint saves you 3.5 cents on every gigabyte, the gap between 4.5 cents and 1 cent. Multiply that by your monthly volume. If the result clears the endpoint's fixed monthly fee, the endpoint wins. In practice, once you're pushing a few hundred gigabytes a month to a given service, the interface endpoint pays for itself and keeps saving from there. A concrete case makes it land. A company running ECS tasks pulled container images from ECR through a NAT gateway and watched processing charges hit $5,000 a month per environment. They added an ECR interface endpoint, and that dropped to roughly $1,780 a month, a significant reduction with no code change at all. Just a different, cheaper path to the same registry. Let's lock in the endpoint rules. S3 or DynamoDB from a private subnet, that's a gateway endpoint, always free, no exceptions. Any other Amazon Web Services service at real volume, that's an interface endpoint, but run the break-even math first. If you want the deeper wiring on how those endpoints actually route traffic, that's the private connectivity episode. Next, we tackle the most expensive path of all, Internet Egress. Internet Egress at 9 cents a gigabyte is where big bills come from, and CloudFront is the tool that cuts it. CloudFront serves cached content from edge locations instead of hitting your origin every time. Two pricing facts matter here. Transfer from S3 to CloudFront within the same region is free. Amazon Web Services made that effective December 2021, and it remains true today. And CloudFront's egress to users runs 8.5 cents a gigabyte, slightly under S3's direct 9 cents. But that marginal rate isn't the real prize. The real prize is the cache hit ratio. Think of CloudFront as a library branch in every neighborhood. Without it, every reader drives to the central warehouse to pick up a book. That's a full price origin fetch from S3. With CloudFront, the popular books are already stocked at the local branch. If 80% of readers find their book locally, only 20% of trips reach the warehouse at all. And since 2024, even those origin fetches from S3 are free. That's why the cache hit ratio, not the per gigabyte rate, is what actually moves your bill. Here's the pricing comparison for 10 terabytes served to end users each month. Direct S3 egress runs about $921. That's roughly 10,240 gigabytes at 9 cents, minus the first 100 gigabytes free. Serve that same volume through CloudFront and the bill drops to around $785 because CloudFront's data transfer out rate is 8.5 cents per gigabyte versus 9 cents from S3 directly. That's a modest 15% saving on pure egress. The bigger win from a high cache hit ratio isn't on the egress line, is that 80% of requests never reach your S3 origin at all, which cuts origin request costs and reduces load on any compute sitting behind it. The last decision is the on-premises link, and it comes down to volume. The site-to-site VPN costs about $36 a month, runs over the public internet with IPsec encryption, and then you can stand it up in minutes. But its egress is billed at full internet rates, 9 cents a gigabyte. Direct Connect costs about $216 a month for a 1 gigabit port and takes weeks to months to provision. But it's a private dedicated line with consistent latency, and its egress is only 2 cents a gigabyte. High fixed cost, low per gigabyte cost. So the rule is the same shape as the endpoint one. Volume decides. When the scenario emphasizes high, sustained data volume, Direct Connect's low per gigabyte rate wins despite the bigger fixed cost. When it emphasizes quick setup, a tight budget, or low and bursty traffic, site-to-site VPN is the answer. And if a question needs encryption, remember Direct Connect isn't encrypted by default. You'd run a VPN over it to add that. Watch what happens at 50 terabytes a month from on-prem to Amazon Web Services. Over VPN, you pay the $36 connection plus 50,000 gigabytes at 9 cents, about $4,536. Over Direct Connect, it's the $216 port plus that same volume at 2 cents, about $1,216. That's over $3,300 a month saved, entirely because the per gigabyte rate is so much lower at high volume. Here's the whole episode as one decision tree. Always ask, where's the traffic going? If it's S3 or DynamoDB, use a gateway endpoint, free every time. If it's another Amazon Web Services service at volume, use an interface endpoint. If it's cacheable internet content, put CloudFront in front. If it's an on-premises link, choose VPN for low volume or Direct Connect for high sustained volume. And whatever's left over goes through the NAT Gateway, which means your job is to make that leftover pile as small as possible. Carry 5 things forward. Data transfer cost is a geography problem. Same AZ private traffic is free, and every boundary crossing starts a meter. The NAT Gateway stacks 3 charges. 4.5 cents an hour, 4.5 cents a gigabyte, and 9 cents a gigabyte on internet egress. For S3 and DynamoDB from private subnets, reach for a gateway endpoint, free, higher performing, and never route it through NAT. Interface endpoints beat NAT per gigabyte once volume clears their fixed fee, and CloudFront cuts internet egress. On-prem, it's VPN for low volume and quick setup, Direct Connect for high sustained throughput. Now let's put it to the test with a quick 5-question quiz. Question 1. EC2 instances in a private subnet write 6 terabytes a month to Amazon S3, currently routed through a NAT gateway. Which change most cost-effectively eliminates the data processing charges for that traffic? Is it A, deploy an S3 gateway VPC endpoint and add its route to the subnet's route table? B, replace the NAT gateway with a self-managed NAT instance? C, add an S3 interface endpoint over a private link? Or D, route the S3 traffic through an internet gateway instead? Run the decision rule from earlier before you answer. The right call here is A. A gateway endpoint for S3 carries no hourly charge and no per gigabyte charge, so it wipes out the NAT data processing fee entirely. The interface endpoint in option C would technically work, but it costs money. The gateway endpoint is free and higher performing, so it's always the better answer for S3 or DynamoDB. Question 2. 2 EC2 instances in the same availability zone talk to each other over their public elastic IP addresses, moving several terabytes a month between them. Why is this generating data transfer charges? Is it A, same AZ traffic is always billed at the cross-region rate? B. Using public or elastic IPS triggers a penny per gigabyte charge each way, even within 1 AZ. C. All traffic between EC2 instances is billed regardless of IP type. Or D. Elastic IPS carry a flat monthly data transfer surcharge. Pause here if you want more time. This one is B. Private IP traffic inside a single AZ is free, but the moment you route it over public or elastic IP addresses, you pay a penny per gigabyte in each direction, the same rate as crossing zones. The fix is simply to have those instances communicate over their private IP addresses. Question 3. ECS tasks and private subnets pull container images from Amazon ECR through a NAT gateway, and the monthly volume is high. What's the most cost-effective way to reach ECR privately? Is it A, a gateway VPC endpoint for ECR? B, keep the NAT gateway since ECR access can't be made private? C, an interface VPC endpoint for ECR over private link? Or D, an internet gateway with a public IP on each task? Think about which endpoint type applies to ECR. It has to be C, and here's why. Gateway endpoints only cover S3 and DynamoDB, so option A is impossible for ECR. An interface endpoint at a penny per gigabyte is 78% cheaper than NAT's 4.5 cents, and at high volume that easily clears its small fixed fee. Question 4. A company transfers 50 terabytes a month from its on-premises data center to Amazon Web Services as a steady, sustained flow, and it wants the lowest data transfer cost. Which connectivity option should they choose? Is it A, site-to-site VPN, because it's quickest to set up? B, a NAT gateway with a public internet path? C, multiple parallel VPN tunnels to increase throughput? Or D, Amazon Web Services Direct Connect, because its per gigabyte rate is far lower at high sustained volume? Got your pick? Let's see. If you said D, well done. At 50 terabytes a month, Direct Connect's 2 cents a gigabyte, Egress crushes VPN's 9 cent internet rate. That's more than $3,300 saved every month, even after the higher fixed port charge. High, sustained volume always points to Direct Connect. Question 5. Let's test a concept from an earlier episode. A private subnet must reach Amazon S3 with no route to the public internet at all, and the solution has to be free. Which single VPC component satisfies this? Is it A, a NAT gateway in a public subnet? B, an S3 gateway VPC endpoint? C, an internet gateway attached to the VPC? Or D, an interface VPC endpoint for S3? Lock in your answer before I give it away. The answer is B. A gateway endpoint routes S3 traffic privately over the Amazon Web Services backbone at zero cost, and it needs no internet path whatsoever. The NAT gateway and internet gateway both require internet access, and while an interface endpoint would reach S3, it isn't free, so the gateway endpoint is the only option that ticks every box. And that's cost-optimized networking, NAT gateway, endpoints, and data transfer done and dusted. Hit subscribe for the rest of the Cloud Architect path and to nudge the algorithm toward other students. I read every comment, so tell me what clicked and where I lost you. Want a different certification next? Name it below, and any notes to improve the pace or style? I want them. See you next time.